So this is the second video in a series of two videos in which we learn how to determine the formula of a compound. In the prior video we have discussed a strategy which I'm going to summarize right here. Okay, this is the compound whose formula we want. We're going to burn it with oxygen and then we're going to generate these products. By analyzing the mass of these products we can calculate the mass of carbon, hydrogen and nitrogen that we have, and by the law of mass conservation then we can know what is the mass of each one of those elements in reagents. We'll calculate the moles, and the moles will give us the coefficients that we're looking for the formula. Okay, so let's actually do the numbers. What we were going to start with is a mass of 1156 grams of the unknown compound. Okay, and then we burn it with oxygen, and we're assuming that the reaction goes to completion, right? So there's no of these reagents left at all. Everything is going to be products. And when that happens, we find that the mass of CO2 that is formed is 0.1638 grams, and the mass of water formed is equal to 0.1676 grams. We don't need to know the mass of nitrogen, as you will see in just a little bit. Okay, so now we know we have the mass of these products. And again, the key is that, well, all of the carbon that we have in this molecule, okay, actually comes from that carbon. Now, this is the mass of CO2, and we only want the mass of carbon. Okay, so the question is, well, how do we get the mass of carbon from CO2? Okay, well, that is done from the calculation of the percent composition. Okay, I'm actually going to illustrate it first with water because we have calculated that number for water in a prior video as well. We have calculated for that the percent mass composition of hydrogen in water was 11.2%. In this case, we need a little bit more precision, so that number more exactly with the more significant figures is 11.19%. Okay, 11.19% of H, okay, in water, or if you have 100 grams of water, then 11.19 grams will be of hydrogen. Now, this percent composition actually is very useful because it allows you to calculate exactly how much of this mass that you have here is of hydrogen. Let's actually see how. All right, so 0.1676 grams of water. Okay, we want to calculate how much of that is hydrogen, and that is exactly what the percent composition actually tells you. Then we multiply this by 11.19 grams of hydrogen for every 100 grams of H2O. Okay, that is exactly the percent composition by mass of hydrogen in water. Then notice that the grams of H2O cancel, and this is going to give me exactly how many grams of hydrogen I have in that mass of water. Okay, and this number happens to be 0.01876 grams of H. Okay, so I already have the mass of hydrogen. Notice that again, the beauty of this setup is that whatever mass of hydrogen I have right here must be exactly the same mass of hydrogen that I had in reagents, because again the reaction goes to completion and hydrogen does not appear in any other product. Okay, so proceeding this way, we can then move on to calculate the mass of carbon that we have in CO2, and then we could actually also do the mass of nitrogen. Now, to calculate the mass of carbon in CO2, we would need to calculate what the percent composition of carbon in CO2 would be. We're not going to do that calculation, but that's something that you guys can do. Right, and that number happens to be 27.29% of carbon in CO2. Okay, so we have 100 grams, 27.20 of CO2, 27.29 grams of those will be solely of carbon. Okay, so we can use that number then to calculate exactly how many grams of carbon we have in this amount of CO2 that has been produced during the reaction. Okay, and we're going to operate exactly the same way. Right, so we have here 0.1638. I realize here that this should be a 6. All right, grams of CO2, but only 27.29 grams are of carbon for every 100 that we have of CO2. Okay, so again, this is a way to tell us how many of these grams is due to solely to carbon. Okay, and when you calculate that number, this happens to be 0.4470. 0.0470. grams of carbon. Okay, so we have the second element. Now, for the third element, which is nitrogen, okay, we could actually do exactly the same thing, but this is actually much easier than it seems, right? That is the total mass of the compound that we have. We already know how much of this mass is due to carbon, which is this amount. We also know how much of this mass is due to hydrogen, which is this amount. So the rest of the mass must be of nitrogen. Okay, so we don't have to do the calculation. We simply could take the difference of those masses and then find right away how much of that mass is of nitrogen, which will be again the remainder. Now the next step then is going to be to try to move on to calculating moles, okay, from this experiment. Now the way that we're actually going to do this is we're going to take an intermediate step, which is to calculate the percent composition by mass of each of these three compounds, but now in the unknown, of each of these three elements in the unknown compound. Okay, so again, we're going to take this mass and then figure out how much of that in percent composition is due to carbon, hydrogen, and nitrogen. And that will be a useful thing to do. Okay, so how do we do that? Again, we've already studied what the percent composition by mass is. You take the mass of the element, divide by the total mass of the compound, multiply by 100, and that will give you the percent composition by mass in that particular element in the compound. Okay, so if we take carbon, we have that 0.04470 grams of carbon divided over the total mass of the compound, which is 0.1156 grams, that is total, multiplied by 100%. Okay, this number happens to be 38.67% in carbon. Okay, so we already know that the percent composition of carbon in that compound is 38.67%. We could do exactly the same thing for hydrogen, which is 0.01876 grams of hydrogen divided over the total mass of the compound, 1156 grams, multiplied by 100%. That will give you the percent composition of hydrogen in the compound, and this number happens to be 16.23% in hydrogen. And then for nitrogen, you do this exactly the same thing, but notice that because the three elements, the 3% have to add to 100, then it's very easy to take 100, subtract these two numbers, and then find out what is the percent composition of nitrogen in that sample. And that number happens to be 45.10% nitrogen. Okay, so we're just a couple of steps from determining what the formula of the compound is. Now we have the percent composition, and again, ultimately what we're interested in is actually finding out how many moles of each we have, and then from the moles it will be trivial to determine what those coefficients are. Okay, so let's calculate the moles. We have the percent compositions, and calculating moles from here will not be very difficult. Okay, what we can actually say is that, well, if we have 100 grams of the compound instead of this 0.5611, okay, if we have 100 grams, then 38.67 of those will be of carbon, then 16.23 of those will be of hydrogen, and the rest will be of nitrogen. Okay, so now we're actually getting masses. Okay, again, if you have 100 grams, we'll have that 38.67 grams of that is carbon. If we have the grams of carbon, then dividing by the molar mass, we can actually calculate the moles, and that will be the step that we actually need. Okay, so again, notice that if you take 100 grams of compound, all of these percentages transform directly into the grams. Okay, so that's what we have. For again, for 100 grams of compound, because these are the percent compositions of this element, you will have that these are the mass of each one of the elements. And from here, we can actually calculate what the moles of each are simply by dividing over the molar mass. Okay, so we go to the periodic table, and we have that the molar mass of carbon happens to be 12.00011 grams per mole. Okay, so when you actually do this, it turns out that this number happens to be 3.220 moles of carbon in those 100 grams. Okay, for hydrogen, we could do exactly the same thing, 16.23. Okay, of hydrogen, we go to the periodic table, find what the mass of molar mass of hydrogen is. It's 1.008 grams per mole. Okay, so we find that this number happens to be 16.10 moles of hydrogen. And finally, we can do the same thing for nitrogen. Divide this by the molar mass, which is provided by the periodic table, 14.007 grams per mole. And the result here is going to be 3.220 mole of nitrogen. Okay, great. So now we have the moles, and again, we know that the moles are directly related to these coefficients. Of course, when we actually have formulas, we never use fractional numbers. We use the simplest or the smallest whole numbers that we can actually get, right? So how do we get low whole numbers from these not whole numbers? Okay, so what you actually do is you take the smallest of them and divide the rest by that one. Okay, so the small of these two numbers, these two are the same and are the smallest, is 3.220 mole. What we're going to do is divide every single one of these numbers by 3.220, and that will give us the ratio of moles of the elements in that compound. Okay, so if we divide this by 3.220, this number happens to be 1. Okay, we divide this number by 3.220, that number happens to be 5. And if we divide this by 3.220, this number happens to be 1. Right, so the ratio of moles are 1 to 5 to 1. Okay, that actually tells us right away what the formula of the compound is. That compound happens to be CH5N. Okay, so we have determined the formula of the compound. Now, one final thought before we actually close off. This is what we call the empirical formula of the compound. Okay, it's not the molecular formula of the compound. And we actually don't know from this problem the difference between the empirical and the actual formula. Okay, this compound could be CH5N, but it could also be C2H10N2, okay, C3H15N3, and then any other combination that gives you a ratio of moles of carbon to hydrogen to nitrogen 1 to 5 to 1. Okay, so again, you notice that in this procedure, which is the elemental analysis through combustion, we can only determine the relative number of moles or atoms of the three elements, but we don't know exactly what the formula is. Okay, so this is what we call the empirical formula. That's what we can determine from this problem. We don't know what the actual formula is, but it's going to be a multiple of this. So how would you determine the absolute formula of the compound from the empirical formula? Well, if you knew the molar mass, then that would be straightforward, right? Notice that the molar mass of this compound is exactly twice that one. The molar mass of this compound is exactly 3 times that one. So from the molar mass, if you know the empirical formula, then it's straightforward to calculate what the absolute formula would be of the compound. Okay? Right, so in summary, we actually have here run the numbers for a practical problem in how to determine the formula of a particular compound using elemental analysis. Again, the goal has been to analyze the mass and the number of moles of each of the elements in the compound, and then we've been able to backtrack the mass and the number of moles and then calculate the empirical formula. And we also have discussed the differences between empirical formula and the absolute molecular formula.